The next measure we'll look at is called the mid-range, and this isn't seen very often, but it is very easy to find. This is the average of the lowest and the highest values. So we're only going to look at two numbers out of our entire data set, the smallest and the biggest, and then we'll average them. This isn't seen very often because it's greatly affected by very, very high or very, very low values. These data values that don't really reflect the rest of the data set. They're outliers. Either way, let's look at how to calculate it. Here we have a data set, and we want to find the mid-range. So in order to do this, we need to average the smallest, which we see as the 1, and the largest, which we see as the 9. So we add those numbers up and divide by the number of numbers, which is 2. So 10 over 2, in this case, our mid-range is 5. Let's do one more. We want to find the mid-range of this data set. Once again, we need the smallest number, which is 9, and the smallest number, which is 14, divided by 2. 9 plus 14 is 23, and 23 over 2 is 11.5. So 11.5 is our mid-range. The last one we'll look at is the mean. In order to find the mean, we need to add the values and divide by the number of things that we have. In general, there are two types of means. There's the sample mean, meaning we're only looking at a sample of data. And this is denoted by X bar, this X with a line over it. In addition, we have the population mean, the mean of the entire population. And that's denoted by this Greek letter mu. The mean varies a lot less than the median and mode. What this means is if I get a sample and I find the mean, median, and mode, and I get another sample and calculate the mean, median, and mode, the mean is going to be a lot closer than the median and the mode of these two groups. In addition, the mean is going to be very useful in computing other types of statistics, like when we get to standard deviation and variance. Here we have a set of data points, and let's say that this is just a sample of data. We use X bar to denote our mean. We're going to add up all of these numbers, 64 plus 72 plus 84 plus 78 plus 80, and divide by the number of things there are. And we can see there are 5 data points here. When we add these up, we get 378 over 5, and dividing by 5 gives us our mean of 75.6. Let's do one more, and this time let's assume this is data for an entire population. We now need to use mu since we're dealing with a population rather than a sample, but we calculate it the same way. We're going to add up all of these data points and divide by the number of data points, which if we count them up, we can see that we have 6 data points. When we add all of these numbers up, we get 153 over 6, and then dividing gives us 25.5 as our average, as our mean.